CSEC Multiple Choice Practice Paper 4B is a continuation of CSEC Multiple Choice Practice Paper 4. Part B consists of 15 problems, the second phase of 15 problems, and this will take us from problem number 16 to problem number 30. How many kilograms are in 1 ton? The solution to this problem is very straightforward. That is, if you have accurate knowledge. Knowing that 1,000 kilograms make a ton will cause the time to be spent on this problem to be equal only to the time that you take to shade the answer. So that is a problem that should not take you much time. Just a simple knowledge problem. If you do not know for sure, you should at least think that it has to be some large figure and begin by considering options C and D. Why it has to be some large figure? Because in our normal metric table we have from milli to kilo. Therefore, we imagine that since a ton is out of that range, then we should be thinking of a relatively large figure. It is good to know also that outside of our regular metric table, which consists of milli, centi, kilo, etc., the most often used prefixes stand for multiples of 10 whose indices are divisible by 3. For example, we have 10 to the power of 3, 10 to the power of 6, 10 to the power of -6, and we may even have to the power of 9 to the power of 12, and so on. Therefore, the answer of choice should be option C, and this has 10 raised to a particular power that is divisible by 3. So this is actually the option of consideration, and no doubt, just by knowing, it is our correct answer. How a housewife divides her budget. Which of the following best displays the answer? Bar chart, histogram, line graph, pie chart. I would use any of the statistic organizational device to display the budget of a housewife, with the exception of the line graph. However, we have to consider one very important word, and that is the important word, best. Which of the following best displays the answer? The suitability of the device chosen will be heavily dependent on some characteristics of the data that is being presented. For option A, bar chart, there we have an example of a bar chart. There is no restriction on the height of the bars, although the tallest bar is at 300 and the grid does not go beyond that figure. So in a bar chart, the height of the bar will have no limit. But in this particular case, we have the tallest bar going up to 300. If there were a larger figure, the statistician would have had to cater for that figure in his diagram. The housewife's budget is a fixed amount that is divided among a variety of categories. This chart is not designed for a fixed amount. It is capable of representing the data, but it is not the most suitable device for doing so, and it is not the most suitable. And we are taking note that we need the one that will best display the budget of the housewife. We are again taking note of the word best. A histogram is a bar chart with consecutive bars joined together. There is really no limit to the height of the bars. The bars are joined as a means of displaying continuous data. In statistics, the opposite of continuous is discrete. The separated bars of a bar chart may be used to display discrete data. The unsuitability of the bar chart and the histogram may be considered on the same premises. Therefore, we have concluded that the histogram may also not be the best. The housewife's budget. There's your line graph of option C. A line graph is best used when displaying data of a chronological nature. That is, data in which it is important to consider what happens over a period of time. Probably the most important consideration in a line graph is its excellence for displaying continuous data. It may therefore be used in other cases in which continuity is the essence of the display. Aspects of continuous data that are easily depicted and observed in a line graph are fluctuations, trends, and constants. By a process of elimination, we may consider that the most suitable device for depicting the housewife's budget is the pie chart. Why is this so? The housewife's budget is a fixed amount of money that is to be shared among the different categories of expenditures. Of the devices discussed, the pie chart is 1. The best for depicting shares or fractions of a whole, and 2. The only one for the consideration of a fixed amount. These fit the type of data under consideration and makes it the most suitable. So there is no doubt that option D, pie chart, is the most suitable for showing how a housewife divides her budget. Another chart that would have been suitable is the proportional bar chart. The whole is considered to be a bar of predetermined length that is divided into the relevant portions. By the way, the chart that we have depicted is only an example of a pie chart and not the one that displays the housewife's budget, because it means that the housewife would have spent his entire budget on food: pizza, chicken, hot dog, hamburger, etc. Which of the following shapes is a square pyramid? A pyramid is a solid with one face that is called the base, and the other sides have a common vertex. So we have one side known, or one face, that is called the base, and the other faces have a common vertex. The only two shapes that fit this description are A and D. Let us mark one face as the base. So in A and D we are marking one face as the base. As we can see, in each case the other faces meet at one point. They have a common vertex. So there we have the common vertex at which the other faces meet. Solid D has a triangular base. It cannot be the correct answer. The base of A is a quadrilateral. Because of the three-dimensional effect, its obvious appearance is not square. Having some familiarity with 3D images, that is how a square usually appears. Besides, there is no other pyramid with a quadrilateral base, so we are sure that our answer is option A. A is called a square pyramid because its base is square. D is a triangular pyramid for obvious reasons. B is a cube, or at least a cuboid. Along with C, they are the two prisms. Prisms are solids with uniform cross-sections. B is a rectangular prism and C is a triangular prism. 299.4 multiplied by 0.05 is approximately which one of those options? There is one clue that virtually gives away, if not the answer to the problem, at least the method that may be used to solve it. All of the options have something to do with 15, and the multiplier has something to do with 5. We may conclude that because 15 is equal to 3 times 5, the other number has something to do with 3. So here we have 0.05, and the answer that we have here has something to do with 15. See, 1, 5, 1, 5, 1, 5, 1, 5. So we have a clue that the number that this is multiplied by has something to do with 3, because it is 3 times 5 that gives 15. So we are sure that the other number has something to do with 3. And there we have our 3. Notice what we have highlighted. We need an approximation of the product. An approximate value of 299.4 is therefore appropriate. We do not imagine that 299.4 can be approximated to 3. The order of the number may be preserved by the inclusion of 2 placeholding zeros. So we have 299, and we are writing an approximate value of what we get when we multiply this by 0.05. That's what we are attempting to do. And we are sure, because of these options, that the answer has something to do with 3 multiplied by 0.05. However, we do not imagine that 299.4 can be approximated to 3. So we are sure that we need 2 placeholding zeros, and that is the appropriate approximation. That we will multiply by 0.05. Even without clues, common sense could have told us that the multiplicand should be approximated to 300. We will proceed to multiply by 0.05. As usual, multiply the numbers as if there is no place of decimal in the problem. In the end, what do? There are 2 decimal places in the problem. The answer needs to have 2 decimal places also. So let us throw in those 2 decimal places. The correct answer is option C. In a class of 120 students, 100 are girls. What is the probability that a student chosen at random is a boy? Probability is found by dividing the number of events that will give a favorable outcome by the total number of events that have an equal chance of occurring. So we need what? To know the total number that will give a favorable outcome. What is the probability that a student chosen at random is a boy? Therefore, we need the number of boys. Any boy will give a favorable outcome. But how many boys do we have? That number, in the end, will have to be divided by the total number of events, or the total number, in this particular case, of students. The class has 120 students, of which 100 are girls. But we need the probability of choosing a boy. I think it is fair to suppose that all of the remaining students are boys. Therefore, we say the number of boys will be the total number of students minus the number of girls. That will give us 20. The number of boys Now we need to divide that by the total number of students. To find the probability of choosing a boy, we need to divide the number of events that will give a favorable outcome, which is 20, by the total number of events, which is 120. The fraction may be reduced by a common factor of 20. 20 into 120 is 6, and 20 into 20 is 1. The correct answer is option A. Now we have another attempt to the same problem. Alternatively, we may first find the probability of selecting a girl. This may be done by dividing the number of events that will give a favorable outcome, which is 100, the number of girls, by the total number of events, 120, the number of students. The fraction may be reduced by a common factor of 20. 20 into 120 is 6, and 20 into 100 is 5. Notice that the answer is option D, but it is not the correct one. The distraction is given in order to catch those who are not too concerned about the correct answer as long as they arrive at one of the answers in the option. We need what is called the complement of the probability that we have just found. So we have 120 students, we have the probability of selecting a girl. Then the probability of selecting a boy will be the complement of that. That means those who are not girls, they are boys. Right, and the complement of the probability of selecting a girl is equal to the probability of selecting a boy. Right, the sum of a probability and its complement is equal to 1. Therefore, in order to find the probability of selecting a boy, if we have the probability of selecting a girl, we will subtract that figure from 1. 1 represents the total probability. So we need what is called the complement of the probability that we have just found. That is, the probability that the student chosen is not a girl. In order to do that, we need to subtract the probability that we have found from the probability of absolute certainty, which is 1. So we have 1 minus 5/6. When subtracting a fraction from a whole number, we may convert the whole number to a fraction that has the same denominator as the whole number. So we have 5/6 here, and this is 1 whole, and 1 whole is 6/6. Alright, so 6/6 minus 5/6, and that is equal to 1/6, which confirms our answer. An article bought for $125 was sold for $175. The percentage profit was, and we need to determine the percentage profit. There is no difficulty determining the profit that is made in this particular situation. Profit is equal to selling price minus cost price. And the selling price is $175. The cost price is $125. When we subtract those, we get $50. This value needs to be expressed as a percentage of the cost price. Profit or loss is always expressed as a percentage of the cost price unless otherwise stated. So when we need the profit or loss percent, we usually take that relative to the cost price unless the statement of the problem says otherwise. We take 50 and we are about to write that as a percentage of 125. There we have it. First, reduce the fraction by a common factor of 25. 25 into 125 is 5. 25 into 100 is 4. Then reduce by a common factor of 5. 5 into 5 is 1. And 5 into 50 is 10. All we have left, these two figures, apart from these ones. 10 multiplied by 4 is equal to 40, so we have 40%. The correct answer is option B. What else may we do? We could have taken an approach in which we first divide the selling price by the cost price. 175 divided by 125. First, reduce the fraction by a common factor of 25. 25 into 125 is 5. 25 into 175 is 7. The original may be represented by 5/5. That we will subtract from 7/5. We are looking at the percentage profit. The selling price expressed as a fraction of the cost price is 7/5. Therefore, we can just look and tell that we have an extra 2/5. So the profit will be represented by 2/5, because the original, which is 1 whole, is 5/5. So 7/5 minus 5/5 is equal to 2/5. Knowing the percentage representation of common fractions, because we should know that the percentage representation of 2/5 is 40%. And that confirms our answer, but we are not done yet. Another way of looking at it is by considering that 7 over 5, or 7 divided by 5, is equal to 1.4. We may subtract the whole, which is 1, which represents the original amount. So we will subtract 1. When we subtract 1, we get 0.4. The percentage representation of decimal fractions should also be known. So if we have a decimal fraction 0.4, the percentage representation of that should also be known. As a matter of fact, it is easy to calculate. 0.4 is actually 40%. So there are quite a few different approaches that we may take to the solution of this problem that will result in the answer. Which of the sets is a subset of the set of 1, 2, 3? What do we mean by subset? If a set A is a subset of a set B, then every element of A is also in B. Therefore, we are searching for, among these, the set of which all of its elements are also elements of this one. Notice that each element of the set in the option is also present in the set that is in the statement of the problem. Notice that we have 1 present here and there, and also 3 present here and there. The set of option A is therefore a subset of the given set. A is correct. Let us see why the sets that are present in the other options are not subset of the given set. First, we have 0. In option B, we are speaking specifically of option B now. The element 0 of this set is not present in the given set. The set in this option is not a subset of the given set. All that we need is one single case in which an element of the proposed subset is not present in the given set for us to conclude that it is not a subset. So all we need is one single case in which we have an element in this one, which is a proposed subset. So we are saying that we need only one occurrence of an element that is not in this one for this not to be a subset of that one. And if we can do the same in the others, no problem. 4. In option C, the element 4 of this set is not present in the given set. The set of this option is also not a subset. It does not matter if all of the elements of the given set are present in the set of this option. So it doesn't matter if all of these elements are present down here. 4 that is present in this set is not present in the given set. The set of option D is not a subset of the given set. So it does not matter if we have all of the elements that are here. As long as we can find one element that is not in this set, then this set is not a subset of this one. It is also noteworthy that instead this set is a subset of this one because all of these elements are present here. The bar chart shows the number of boys with a given number of books. The total number of books is. The graph is telling us the number of boys that have a particular number of books. If 8 boys are associated with 5 books, this means that each of the 8 boys has 5 books. This will make a total of 8 multiplied by 5, which is equal to 40 books. Let us write down the products associated with each bar. So that bar, 5 boys, and each has 1 book. So 5 multiplied by 1. 4 boys, each has 2 books. So 4 multiplied by 2. Right here we have 7 boys. Right there, 7 boys, each has 3 books. So every single one, each one has 3 books. So 7 multiplied by 3. And finally, 5 boys, each has 4 books. Lovely. Let us now calculate the products. 5 multiplied by 1 is 5. 4 2 is 8. 7 3 is 21. And 5 4 is 20. Finish up by adding the numbers. So we will add all of those numbers. And the result is 54. And that turns out to be option D. We will take a second look at problem number 23. The best way to view this problem is as one involving a variable x, which is the number of books, and associated frequency, which is the number of boys. The total number of books will be the sum of the product of f and x. The reason why I'm saying that it is the best way of viewing it, it is more suited for the jargon of statistics that makes use of a particular variable and the number of times that each value of that variable occurs, and the number of times is called the frequency. It is customary for us to complete the table, then make the calculations. That is how we do it normally when doing statistics. But on this occasion, we will calculate the values of fx while completing the table. So we are more going to the jargon and what is more in line with what we are accustomed to in statistics. we have x, and we have the number of boys, which will represent the frequency, and we have fx, which is frequency multiplied by x. And of course, x represents the variable, and f represents the number of times that the variable occurs. In this particular case, x is equal to 1, so the value of the variable is equal to 1. F is equal to 5. The number of times that the variable occurs is equal to 5. And fx is equal to 5 multiplied by 1, which is equal to 5. And we have that represented in the table. Then we have the number of books. The value of the variable is 2. The number of times that that variable occurs is 4. And the value of f multiplied by x, which is fx, is equal to 8. And the other will follow in the same vein. Finally, the value of the variable x is 4, the number of times it occurs is 5, and the value of fx is 20. We do not need the mean, so we will not divide the sum of fx by the sum of f, as is customary when we are finding the mean of a frequency distribution in statistics. All we need is the total number of books. This is equal to the sum of fx, which is, of course, 54. The diagram shows the graph of y is equal to x multiplied by all of x minus 2. The minimum point is, as a matter of fact, we need to find the minimum point on that graph. The equation of a curve can prove to be very important in determining many of its characteristics. However, in this particular case, the curve is drawn on a graph that contains important details. The equation is therefore not necessary in solving this problem. So although we can use the equation of a curve to determine most, if not all, of its characteristics, in this particular case, we are not going to use the equation of the curve, because we have a detailed graph right there that will serve as a visual and will help us to solve the problem very easily. The minimum point is, and that is what we need to find, the minimum point on the curve is the lowest point, which is that one right there, the lowest point. Now that we have located the minimum point, all we need to do is determine its coordinates. Remember that the x-ordinate will be placed first. So we have our system that we will use to determine the coordinates. As a matter of fact, all we need is a pair of brackets and provision for the two numbers to be separated, and they will be separated by that comma. So we have the x-ordinate that goes to 1 there, and we have the y-ordinate that will take us down to -1, and that is all there is to it. We go this way for the x 1 unit, as we have it there, then we go this way for the y 1 unit, but 1 unit in the negative y direction, so we have -1 for the y. The correct answer is option D. Sometimes when we are given a problem, we are overpowered by the amount and the type of information that is given. It is for us to use our knowledge coupled with our common sense and see the simplicity that may exist in solving a problem. It is not impossible to use the equation of the curve in solving the problem, but it is not necessary, and it will be more time consuming. So the use of the equation of the curve would have been more time consuming and of course unnecessary. OAB is the sector of a circle such that angle AOB is equal to 60 degrees and OB is R units long. The area of OB is, we need to find the area of this sector. A sector is a fraction of a circle. We will use this consideration in determining the area of the sector. The area of a circle is given by pi r squared. Since the sector is a fraction of the area of the circle, to find its area, we need to multiply the area of the circle by the fraction that it represents. The fraction is equal to the angle associated with the sector, which is 60 degrees, divided by the angle of an entire revolution, which is 360 degrees. So we have the fraction represented by the angle representing the sector, and of course the angle representing the entire revolution or the entire circle. So we have 60 divided by 360. Reduce the fractions by a common factor of 60. 60 into 360 is 6, and 60 into 60 is 1. So we have 1/6. The answer may be written with the fraction as the prefix. So instead of having the 1/6 after the pi r squared, we may write the 1/6 before the pi r squared. The correct answer is option D. As we have it there, the correct answer is option D. The problem is not only testing your ability to make the calculation, it is also testing your knowledge of the details of the formula of the area of a circle, because some student may use pi r instead of pi r squared and end up with this one, and some may use 2 pi r squared, then you will get this one, and so on. Tom bought a pen for $60 and sold it to gain 20% on his cost price. How much money did he gain? When a problem appears to be easy, most people think that it is a trick question. There's really no trick question in mathematics. Although it appears to be easy, serious considerations must be given to the information that is given and what is required. There we have some of the important information highlighted. It is clear that the gain is 20%. Then we are asked, how much money did he gain? The question is 20% of what? So we need 20%, but 20% of what? So here we have some other bits of information highlighted. Bought a pen for $60, 20% on his cost price. There we have 20% on the cost price. The cost price is what the pen was bought for. So the cost price is actually the $60 that Tom paid for the pen. All we need to do is find 20% of $60. $20 is equal to 20 divided by 100. and of course that is equal to 0.2. Therefore, to find 20% of $60, we need to multiply it by 0.2, which is very simple actually. As usual, when multiplying numbers that have decimal places, multiply as if there is no decimal place. So you multiply 60 by 2, you get 120. The problem has one place of decimal. So will the answer. So we have this one place of decimal only. The answer needs to have one place of decimal. The correct answer is option A, $12. That is all there is to it. If a problem cannot be answered purely by the information that is given, it is a trick question and it is not mathematics. When the sum of x and 6 is multiplied by 2 and the result added to 3, the answer is 5. The statement above may be written. How may we write that statement above? And we'll take this statement, the entire statement, one section at a time, dissecting, as it were, the entire statement. Sum of x and 6. The sum is the result of adding. We need to add x and 6. X plus 6. Multiplied by 2. The entire sum needs to be multiplied by 2. The appropriate way to demonstrate this is to place x plus 6 in brackets. In this case, the multiplication sign is not necessary, as whether a number precedes or follows the brackets without any arithmetic operation separating them, the assumed operation is multiplication. So we need to just put x plus 6 in brackets, and of course, preceding the brackets we have 2. We may put it after, but it is more customary to put it before. We have chosen to cause the 2 to precede the bracket in keeping with what we have in the options. So we have that represented in the option here. So we cause it to appear or to resemble the one that we have in the options. And also is the typical way of demonstrating such operations. So it is the typical way of demonstrating an operation in which a single number is multiplied by others that are enclosed in brackets. Result added to 3. The statement says that the result is added to 3. We may add 3 to the result because addition is commutative. Order of operands does not affect the sum. So, although the statements say the result should be added to 3, we may also add 3 to the result because addition is commutative, so the order in which we add numbers does not affect the sum. There we have it. Answer is 5. The answer is what the entire statement is equal to. There we have it. The correct answer is option D. If x is an integer that satisfies the inequalities, 4 is less than x minus 2 is less than 8. That is, x minus 2 is between 4 and 8. But 4 and 8 are not to be included. We have that inequality, 4 is less than x minus 2 is less than 8. And then we need to find what the value of x may be by considering these options. We have the inequalities written there again. And we are highlighting the negative 2. Whenever we have inequalities written in that form, or whatever form, it will be most explicit if the x is all by itself. We may therefore eliminate the negative 2 from that section. So we will have a clearer view of the inequality if we just have x by itself. That will be done by eliminating the negative 2 from right there. Just like in any other equation or inequality, if we need to eliminate a symbol or number, we apply its inverse. In order to maintain its integrity, that is the integrity of the inequality or equation, we need to apply the same thing to each section. So in order to eliminate a negative 2, we need to add 2. However, in order that the inequality be not affected by the adjustment that we make here, we will make the adjustment throughout the inequality by adding 2 to each section. The opposite of minus 2 is plus 2. We therefore need to add 2 to each section. In which case we will end up with 6 is less than x is less than 10. That is, x is between 6 and 10, but not to include 6 and 10. According to the two inequality signs, any value chosen cannot be equal to 6 or 10. Since the number must be between 6 and 10 and cannot be equal to 10, the correct answer is 7. So the number must be between 6 and 10. It cannot be 6 and it cannot be 10 because we do not have less than or equal to. We have strictly less than, and we have that same thing right here. So we are sure that it cannot be 6. So the one that is between 6 and 10 is 7, and the others are out of the range. Option D is correct. The arrow diagram shows a function. Which of the following best describes the function? F such that x maps to y. The statement may be read, f is such that x maps to y. This is a general statement for every function and may not be a description of any particular mapping. So this is a general representation. It represents all functions, and it cannot be a representation of a particular mapping. So we are sure that is not the correct one. What about y is equal to x? The statement in this option is saying that the values of y and x are equal. They are the same. That is not the case in the given mapping. Option B is not correct because we have 2 and we have 5. They are not the same. 5, we have 8. They are not the same. But we are saying that the mapping is saying that y is equal to x. They are not equal. Option B is not correct. We move to option C. This statement is saying that if we add 3 to the value of y, the result will be the value of x. This is not true because if we take a single value of y, say 5, there we are choosing 5, the value of y, and what do? Add 3 to it because we say y plus 3, add 3 to it. What do we know? The result is surely not equal to the value of x. So if we have 5 plus 3, this is the value of y that we have chosen. This is the corresponding value of x. Right there. The corresponding value of x is this. But we get 5 plus 3 is equal to 8. And we have x is equal to 2. Therefore, x is surely not equal to y plus 3. Finally, only D remains, which must be the correct answer. But we may show that in each case that we add 3 to the value of x, the result is equal to the value of y. So let us begin. 2 plus 3 is equal to 5. 5 plus 3 is equal to 8. 8 plus 3 is equal to 11. 11 plus 3 is equal to 14. So although D is the only option that remains, we may also show that it is correct, although the process of elimination would have confirmed that a long time ago. The answer is option D. We did not have to use the process of elimination. Sometimes examiners expect us to use it and make D the correct answer. So if we can just arrive at the answer without using the process of elimination, that would have been the correct thing to do. Because sometimes examiners expect us to use the process of elimination and make D the correct answer. This causes the problem to consume the maximum time. Use common sense and mathematical principles to arrive at your answers in the shortest possible time. So it is not always the best thing to do. That is, to use the options, or to take a look at the options and to figure out from that which one is correct. Sometimes it is better for you to use correct mathematical principles and common sense, arriving at the answer so that you do not have to exhaust the options. In which of the following are the fractions arranged from the smallest to the largest? Before attempting to solve this problem, we will establish a principle that will help us in understanding it. Let us take a number, say 60, and gradually increase the number that we will divide it by. So we are choosing 60, and we are increasing the number that we are dividing it by. So we have 60 divided by 1 is 60, 60 divided by 2 is 30, 60 divided by 3 is 20, 60 divided by 4 is 15, 60 divided by 5 is 12. And we are increasing the number that we are dividing by. And of course we are decreasing the quotient. And what about the number that we are dividing by? What do we call it? Notice that as the divisor increases, the quotient decreases. As the divisor increases, the quotient decreases. And arrange from the smallest to the largest. An arrangement from the smallest to the largest, as required by the statement of the problem, is in ascending order. That is, increasing. Ascending order, increasing. We have discovered that as the divisor increases, the quotient decreases. We will therefore expect that a decrease in the divisor will result in an increase of the quotient. Let's repeat that. We have discovered that as the divisor increases, the quotient decreases. We will therefore expect that a decrease in the divisor will result in an increase of the quotient. So we need to find ourselves in a situation in which we are decreasing the number that we are dividing by. And in that particular case, we will be increasing the quotient. The option in which the divisor is consistently decreasing is D. In that option, the fractions are arranged in ascending order because we keep dividing by a smaller number each time. Therefore, the size of the fraction is increasing. Option D is correct. In B and C, the increase or decrease is not consistent. They cannot be the answer. Take a second look at fractions in which the numerator is not constant throughout. So we also need to take a look, because we may take this principle and we may just run along with it. And sometimes we neglect very important bits of information. Say for argument's sake, we have another problem in which the denominator is decreasing, like this one. And we are quick to say that that one is the correct answer. But it can only be the correct answer if the figure that we have in the numerator is the same. So we need to pay special attention to what figure we have in the numerator. But in this particular case, as in all of the cases of the fractions that we have in the options, we find that the numerators are all equal. Therefore, we need not worry. We may just apply the principles exactly as we have them right there, or we have just discussed. But if the numerators had a mixture, then we would have had to give other consideration to the solution of the problem.